Welcome to Astronomy Daily. I'm Anna, and I'm here with my co-host Avery to bring you the latest and most fascinating news from across the cosmos.
Hey everyone, Avery here, and wow, Anna, do we have some incredible stories for you today? From spacecraft having technical hiccups to black holes completely flipping their magnetic fields, this has been an absolutely wild week in space.
It really has been. Plus, we're talking about ancient comet impacts that may have changed human history, and an asteroid that's going to give us the show of a lifetime in 2029. But let's start with something happening right now in orbit.
Right, so Northrop Grumman's new Cygnus XL spacecraft is having some propulsion troubles. This was supposed to be its debut mission, and it's a big deal because this thing can carry 33% more cargo than the standard Cygnus.
We're talking over 11,000 pounds of supplies. That's a significant upgrade in capacity. But during the orbit raising burns, the maneuvers to get it to the right altitude to meet the International Space Station, something went wrong with the propulsion system.
And this pushed back the planned Wednesday docking. NASA astronauts Johnny Kim and Zena Cardman were all set to capture it with the Canadarm2. I have to imagine there's some disappointment up there. They've been preparing for this.
Absolutely. And this comes after we've had previous Cygnus damage incidents. So cargo resupply to the ISS has been a real challenge lately. The crew up there depends on these regular deliveries for everything from scientific equipment to basic supplies.
The technical details are quite interesting here, Avery. The Cygnus XL uses a new service module design that's significantly larger than the standard version. It's powered by enhanced Antares engines and was specifically designed to handle heavier payloads for NASA's Commercial Resupply Services program.
And what's really crucial here is that this isn't just about delaying one delivery. The ISS operates on a tight logistics schedule, with multiple international partners coordinating everything from crew rotations to scientific experiments. When something like this happens, it creates a domino effect that can impact research timelines for months. It really highlights how complex these missions are. I mean, you've got to get the timing perfect, the trajectory perfect, and every system has to work flawlessly. When you're dealing with spacecraft moving at 17,500 miles per hour, there's no room for error.
Speaking of things that seem impossible, let's talk about something that happened 55 million light years away that's completely baffled scientists. The Event Horizon Telescope has been monitoring M87 Star, that supermassive black hole we first photographed back in 2019.
Oh, this is incredible. So they've been watching this black hole from 2017 to 2021, and in that time, the magnetic field polarization around it completely reversed direction. The researchers are calling this totally unexpected.
We're talking about a black hole that's 6.5 billion times the mass of our sun. That's almost incomprehensibly massive. And somehow, over just 4 years, its entire magnetic field structure flipped.
What's even more amazing is that they also captured images of the base of the particle jet for the first time. That stream of matter and energy that gets shot out from near the black hole at nearly the speed of light. This is groundbreaking observational astronomy.
What's fascinating is how this discovery relates to the broader physics of accretion disks. The magnetic fields around black holes are generated by the swirling matter in the accretion disk, that superheated material spiraling into the black hole. For the entire field structure to flip means something fundamental changed in that disk's behavior. And the implications go beyond just M87. It could help us understand how supermassive black holes influence galaxy formation and evolution. These magnetic field changes affect the jets, which in turn influence star formation rates across entire galaxies. We're talking about cosmic processes that shape the universe on the largest scales imaginable.
And it's challenging our current models of black hole physics. I mean, we thought we understood how these magnetic fields behaved around black holes. But clearly, there's still so much we don't know. It makes you wonder what other surprises are waiting out there.
It really does. Now, let's shift from the cosmic scale to something much closer to home, but equally fascinating. There's new evidence supporting a really controversial theory about what happened to early human civilizations 12,000 years ago.
The Younger Dryas Impact Hypothesis. Researchers have found shocked quartz at 3 different Clovis culture archaeological sites: Murray Springs in Arizona, Blackwater Draw in New Mexico, and Arlington Canyon in California.
And shocked quartz is key here, Anna. This stuff only forms under extreme pressure and heat. We're talking about conditions similar to nuclear explosions or massive impact craters. It's not something you find lying around naturally.
The theory suggests that an exploding comet 12,000 years ago triggered this abrupt cooling period called the Younger Dryas. And this wasn't just a climate event. It may have caused the extinction of megafauna like woolly mammoths and contributed to the collapse of the Clovis culture.
It's fascinating to think that a cosmic event could have such profound effects on early human civilization. I mean, we're talking about a period when humans were just developing agriculture and settling into more permanent communities.
Exactly. And finding this shocked quartz at multiple sites really strengthens the case. This has been a controversial hypothesis for years, but the physical evidence is mounting. It shows how vulnerable we are to cosmic events even today.
Speaking of cosmic impacts and their effects, we should talk about something exciting happening in exoplanet research. The James Webb Telescope has been making incredible discoveries about planetary atmospheres. And there's one recent finding that's particularly intriguing.
You're talking about WASP-96b, aren't you? The Webb telescope has been analyzing its atmosphere in unprecedented detail, and what they found is revolutionizing our understanding of how water vapor and clouds behave on exoplanets. This hot gas giant, located about 1,100 light years away, is giving us insights that could apply to thousands of other worlds.
Exactly. What's remarkable is that Webb can detect individual molecules in the planet's atmosphere as it transits in front of its star. We're seeing clear signatures of water vapor, along with evidence of clouds and haze. But here's the kicker. The atmospheric composition is nothing like what our current models predicted for planets like this.
This is why Webb is such a game changer. Each exoplanet atmosphere it analyzes is like opening a new chapter in planetary science. And as we build this database of atmospheric compositions across different types of worlds, we're getting closer to answering that fundamental question. What makes a planet capable of supporting life as we know it?
Which brings us perfectly to our next story, Apophis, the so-called god of chaos asteroid. Now, before anyone panics, this is a completely safe passage, but it's going to be absolutely spectacular.
On Friday, April 13th, 2029, and yes, that is Friday the 13th, this 340-meter asteroid will pass closer to Earth than our geosynchronous satellites. We're talking about just 5.9 Earth radii away.
The timing couldn't be more perfect for a dramatic effect, right? Friday the 13th and an asteroid called the God of Chaos. But here's what's really exciting. Up to 2 billion people might be able to see this with the naked eye. That's 4 times more people than watched Neil Armstrong step onto the moon.
And this kind of close approach only happens once every 7,500 years. So this is truly a once in multiple lifetimes event. The scientific community is incredibly excited. Europe's planning the Ramses mission, Japan has Destiny Plus, and NASA is sending OSIRIS Apex.
It's going to be an unprecedented scientific opportunity. We'll be able to study how Earth's gravity affects the asteroid's rotation, surface, and internal structure. Plus, imagine the photos and videos we'll get as it streaks across the sky.
The scientific planning for this event has been in the works for years, Avery. The Ramses mission from ESA will actually arrive at Apophis before the 29 encounter to study it in its natural state. Then they'll observe in real time how Earth's gravitational field changes the asteroid's shape, spin, and surface features.
And NASA's OSIRIS Apex mission is equally exciting. This is actually the same spacecraft that visited asteroid Bennu and collected samples. It's being repurposed to study Apophis, and it'll use its thrusters to kick up material from the surface so we can analyze the asteroid's composition in detail. We're essentially getting a free asteroid sample return mission.
I can only imagine the social media explosion that's going to happen that day. 2 billion people all looking up at the same time, watching this same cosmic visitor. It's going to be incredible. You know, while we're talking about future cosmic events, Avery, we should mention some significant developments in lunar science. NASA's recent analysis of data from the Lunar Reconnaissance Orbiter has revealed something fascinating about the moon's south polar region. There may be significantly more water ice trapped in permanently shadowed craters than we previously thought.
This is huge for the Artemis program, Anna. The presence of water ice isn't just scientifically interesting. It's potentially mission-critical for long-term lunar habitation. We're talking about a resource that could be converted into drinking water, oxygen for breathing, and even rocket fuel for future Mars missions. The moon could literally become a refueling station for deeper space exploration. Now, before we wrap up, we've got a couple of quick bonus stories that I think our listeners will love. There'll be this amazing triple conjunction on September 19th, where Venus, Regulus, and a crescent moon will form what looks like a smiley face in the dawn sky.
Oh, that should be adorable. And there will be rare occultations happening too. Sometimes the universe just seems to have a sense of humor about these alignments.
And speaking of surprises, there was an unexpected aurora storm caused by something called a positive polarity island in a coronal hole. It created a G3 geomagnetic storm that was visible as far south as Texas.
People in Texas seeing the northern lights? That's just wild. It really shows how dynamic and unpredictable our sun can be. These space weather events are becoming more important to track as we become more dependent on satellite technology.
Absolutely. Well, that wraps up another incredible day in astronomy news. From spacecraft delays and magnetic field reversals to ancient impacts and future asteroid encounters, the universe never stops surprising us.
It really doesn't. Thanks to all our listeners for joining us on Astronomy Daily. Keep looking up, stay curious, and we'll see you next time with more amazing stories from across the cosmos.
Until next time, this is Anna and Avery signing off. Clear skies, everyone.
Astronomy.